Welcome back to Knowledge Academy's YouTube channel. In the previous video, we introduced Naïve Bayes and broke down how it works. Now, let's dive deeper into its types, see it in action with Python, and discuss its advantages and limitations. By the end of this video, you'll not only understand when to use Naïve Bayes, but also how to implement it step by step in Python. Let's get started. Now let's put theory into practice and build a multinomial Naïve Bayes classifier to classify text data. We'll use a simple dataset of movie reviews labeled as positive or negative. Step 1. Import libraries. We will import pandas, then train test split. This divides the dataset into training and testing sets. Next, CountVectorizer. This converts text into a numerical format using the bag of words approach. Then Multinomial NB, which implements the multinomial Naïve Bayes algorithm. At last, the accuracy score. This measures the performance of our model by comparing predictions to actual results. Now that we've set up the tools, let's move on to preparing our data. Step 2. Load the data. We'll create a small data set of movie reviews and labeling is shown. Then we can check the data frame as well. This dataset has review column with the text of the movie review and label column with the sentiment of the review positive or negative. In real-world scenarios, such datasets are typically much larger and loaded from external sources. Step 3. Split and pre-process the data. We'll split the data into training and testing sets using train test split, then in bracket df, the name of both columns separately, having test size equal to 0.2 and random state 42. Here, 80% of the data is used for training and 20% is reserved for testing. Step 4. Vectorize the data. Since machine learning models work with numbers, we need to convert text data into a numerical format. So for that, we will vectorize the data using CountVectorizer. Then we will use fit transform, which learns the vocabulary from the training data and transforms it into a bag of words representation. Whereas transform converts the test data into the same numerical format using the learned vocabulary. Now our text data is ready for modeling. Step 4. Train the model. Let's train a multinomial Naïve Bayes model. First, we will use multinomial NB to initialize the multinomial Naïve Bayes classifier, ideal for text data with count-based features. Then fit xtrain vector, ytrain in bracket, to train the model using the vectorized training data xtrain vector and corresponding labels ytrain. Here, the fit method allows the model to learn the relationships between word frequencies and sentiment labels from the training data. Step 5. Make predictions and evaluate. Now, let's test the model's performance on the test data. So for that, we will use NB model. Predict on X-test vector, then for accuracy, we will use accuracy score on Y-test and Y-predict W. Then we will print the accuracy by using function as shown. Predict uses the trained model to classify the test data. Accuracy score compares the predicted labels with the actual labels to calculate the model's accuracy. For this small dataset, you might see an output like accuracy equal to 100%. This perfect accuracy is expected since the dataset is tiny and straightforward. In real-world applications, results will vary with more complex datasets. Naïve Bayes is a simple yet powerful algorithm for classification tasks, especially with text data. It's fast, interpretable, and easy to implement, making it a great starting point for beginners in machine learning. If you found this tutorial helpful, don't forget to hit the like button, subscribe for more videos, and share your thoughts or questions in the comments below. Thanks for watching, and I'll see you in the next one.